Oh, I did that. Welcome back. Thanks for joining us, Bob. That had so much content. Like, I'm excited for pretty much every one of the sessions, which is why I'm here. I'm excited to watch along with everyone. Thanks everyone for joining, seeing great comments. There's also a lot of people that are presenting later are in the comments right now moderating. I saw Jay in there, I saw Amin in there. So feel free to ask questions early as well. You'll get some links, but then stick around for the sessions. I am very excited for the ACK session coming later and EKS Anywhere. If you're looking at running EKS on-prem, it's I think maybe biased, but a great solution. So stick around for that too, because we had a cool demo for that. And as Bob was mentioning, AWS security is just like #1. Doesn't matter what we're doing, security has to be there. And so this next session, bringing up Jeremy and a panel of some great hosts to talk all about security. Jeremy, your video's small. I don't know why that is. It might be a Zoom issue.
Could be.
That's all right.
All right.
We can still hear you fine, so this is great.
Good.
But this is a session all about EKS security. And I'm gonna let Jeremy take it away because we got a lot of good questions. Feel free to ask in the chats if you have questions about security. And go ahead, Jeremy, let's kick it off.
Okay, let me start by sharing my screen.
Yeah.
I'll put this in presentation mode. Great. So I thought I'd start by talking about the shared responsibility model. Also, I'm joined today by my friends Rob Clark and Micah Hausler, and I'm going to be facilitating a conversation today about container security. But as a lot of our viewers may know, AWS has this model known as the shared responsibility model. And this is important because it delineates the things that our customers are responsible for as consumers of AWS services and the things that AWS is responsible for as a provider of those different services. And as I'm sure a lot of you are aware, we provide global infrastructure on which our services are built, and we're responsible for securing that infrastructure. And then this demarcation between the things that you are responsible for and things that we are responsible for moves or changes as you use different services. So we have a core set of infrastructure services where you are responsible for the lion's share of security. Again, we're responsible for securing our global infrastructure, the physical data centers, the hardware, the virtual machine software that we run on that hardware, and so forth. But then customers are responsible for things like controlling access to the resources that they provision within AWS using identity and access management controls. They're also responsible for things like server-side encryption or encryption in transit and so forth. But then as you start consuming higher order services, things like container services, AWS assumes a greater share of the responsibility. When we look at EKS, which we'll do so momentarily, AWS is responsible for managing the control plane for Kubernetes and other elements of the service as you use different features. And then we have services that are abstracted further, things like Lambda or say EKS Fargate or App Runner, where AWS assumes yet an even greater share of the responsibilities. And for additional information about security best practices and the shared responsibility model, you can visit this link here below. Now, if we look at an EKS cluster, it's really divided into two parts. We have the EKS control plane, which consists of the API server, the controller manager, the scheduler, along with etcd. And AWS is responsible and has been responsible for managing that component of the service since its inception. When you use self-managed workers with EKS, you are responsible for your data, how you grant access to different resources that run within your cluster. You're also responsible for Kubernetes specific resources, things like network policies, RBAC bindings, quotas, limit ranges, and so on. But you're also responsible for worker node scaling, the VPC configuration, and so on. The only change to this slide that I'll mention is around cluster add-ons. So earlier this year, we released support for EKS add-ons. Today, we support 3 add-ons that you run within your cluster, the VPC CNI, kubeproxy, and core DNS. Now, this is an optional component that customers can use where we'll manage the lifecycle of those add-ons. And going forward, we're looking at adding support for additional add-ons to alleviate the undifferentiated heavy lifting that goes into managing those add-ons. Now, as the service has evolved, we've offered a greater amount of management. So with managed node groups, we now partially assume responsibility for the life cycle of the data plane or your worker nodes, which is why the OS, the kubelet, and CRI are shaded here, or we're using a gradation shade to depict that, because we maintain an EKS optimized AMI. We're responsible for the life cycle of that AMI, and we give you a way to orchestrate the deployment of new AMIs as they're released. And then finally, with AWS Fargate, we're assuming full control of the data plane in that we're responsible for the infrastructure scaling associated with node scaling. We're also fully responsible for updating the OS kubelet, CRI, and the AMI that we use for running EKS Fargate pods. So with that as the backdrop for our conversation today, let me stop sharing my screen. I thought I would start by asking Micah how we secure our EKS binaries, not only for the AWS, the EKS service itself, but also for variations like EKS Distro and EKS Anywhere.
Yep. Yeah, thanks, Jeremy. As Bob mentioned, we launched the EKS Distro project almost a year ago now at our reInvent 2020. EKS Distro is the same Kubernetes that EKS uses on the managed control plane, but you can run it yourself. So that's available as container images, as binaries as well. And it's frequently updated for whether it's Kubernetes CVEs or if it's a container image. If there's a CVE and a container image, you can get the latest builds provided by AWS. We use open source tooling. The build code for that is all open source. It's on GitHub. You can see the select set of patches that we apply to Kubernetes for security, operational performance reasons, and those are all provided through standard AWS services like ECR and HTTP. With the implementation for us is CloudFront and S3. We're using our own services here, but that's a little bit about EKS Distro.
And when should customers expect new versions to become available? New versions of those binaries?
Yep, we release the same frequency as EKS. So when EKS supports a new version of Kubernetes, EKS Distro will produce those builds for you to run yourself. You can run it with COPS, you can run it with EKS Anywhere, but we do the same frequency as EKS.
Great. Another area that our customers often have questions about is multi-tenancy. There are various ways to approach multi-tenancy with Kubernetes. Kubernetes has native support for namespaces, which allows you to partition your cluster and give different teams the ability to deploy their applications into those namespaces. But how should our customers really be thinking about multi-tenancy and Kubernetes? And this is for Rob.
Yeah, that's a really good question. There's different challenges because one of the things we've heard from customers is that multi-tenancy maybe means a different thing to them than it does to us as a massive provider, right? It's probably true to say that anybody running a Kubernetes cluster at significant scale is mixing workloads of different levels of severity, or those that have maybe different types of data within them. It's important to recognize that with any kube cluster, the most robust security boundary is the edge of the cluster. So if you're running very sensitive workloads, you should always, the safest option is always to run in a separate cluster. And the reason for that is that many components of the Kubernetes control plane can be considered to be really single tenanted, Kube API being the best example. A compromise of that, or a compromise of something that has privileged access to calls within Kube API, can be disruptive to an entire cluster. So that's the very defensive security position. It's also the case that not everybody can deploy kind of clusters for every single tenant that they consider on their system. So for them, there's a few options available. As you mentioned, namespaces exist as a natural boundary within a Kubernetes cluster. It's also the case, though, that not all resources currently are namespaced. So it's not a cure-all, but it can be useful. There are a few options available to customers if you're going kind of bottom up and thinking about container breakouts. Looking at different mechanisms for isolating a pod is a very useful and sensible step. One way, obviously, we can do that within EKS is to use Fargate. Fargate isolates pods within a virtual machine boundary, which we understand to be very robust and a very nice way of containing dangerous workloads. One of the challenges there for some customers is that your ability to deploy things like daemon sets is very limited. So it really depends on how you are considering about securing your entire cluster kind of holistically. So the key point here really is to understand that your workloads and their attack surface and the data within them are really key to your design decision about whether you're going to go ahead and deploy an independent cluster, whether you feel comfortable separating things by namespace, or whether you feel comfortable co-locating pods within specific namespaces. With whichever of these you choose, it's important to, and I think we'll talk about this a bit later, is consider how you're going to do policies and governance around what these pods can do. The biggest risk when running a multi-tenant cluster isn't necessarily the specter of a container breakout, although it's where most of the security industry likes to focus because it's exciting stuff. It's actually in basic misconfigurations of things like RBAC. I'm less worried about somebody breaking out of a container than I am what a sufficiently authorized container can already do if it is subverted without an escalation of privilege. And I think a lot of the time in the industry, we spend a lot of time focused on thing one, a breakout, and far less on thing two, which is like the policy and the RBAC and constraining whatever that container can do as an authorized entity. Micah, do you have any thoughts you want to add?
No, I think that's a really, it's a really good point. I think that as with most questions, when you start touching on security, there's a lot of nuance. As you called out at the beginning, it very much depends on a lot of the, on the organization and what their profile is and what they're doing. Great.
And that actually coincides with the results of the Red Hat State of Kubernetes Security Survey, where like half of the respondents reported that they worry about misconfigurations within their cluster will lead to breaches. So you mentioned that Fargate might be a possibility or as a way to provide isolation. How should customers think about using Fargate? You mentioned that it doesn't yet have support for things like daemon sets, but does it provide ample isolation for a multi-tenant environment? And are there advantages to using Fargate, say, instead of an EC2 instance?
So, as Nita said, security is nuanced. The most secure way to run Kubernetes is probably to stick EKS anywhere on a cluster, put the cluster in a shipping container, and drop that in the middle of the sea and never worry about it again. Right? We can be reasonably confident that it will be secure in that state. And I bring that up because we run into statements around our solution in security all the time, and it's not helpful. So what EKS Fargate does is adds really defense in depth for Kubernetes applications. It allows you to isolate each pod within a virtual machine, and that boundary prevents access to host-based resources that are used by other pods. So in the event of a container escape, which, as I said, is a common thing that we are concerned about, applications in those pods can't gain access to any other resources. In addition, the RBAC and things are appropriately configured out of the box there. Using EKS Fargate doesn't actually change your responsibilities under the shared responsibility model that you described earlier. It's just adding this layer of defense, this layer of isolation. Obviously, it integrates nicely into the EKS and AWS ecosystem and allows you to kind of manage your pods in a slightly more native way. But I would remind anyone, think about the governance and controls you have in your cluster. EKS Fargate is excellent, and it adds a robust layer of defense in depth. But as we're learning with Kubernetes in general, as an industry, there's no silver bullets here. Right? It's all about how you're configuring things up and down your stack to try and be as secure as possible.
Great. And I know that within the last 12 months or so, there have been several Kubernetes-related CVEs. When we look at the shared responsibility model, AWS is responsible for patching the control plane as these CVEs are announced. How are we dealing with this, and how do customers know that we're applying patches in a timely fashion to their clusters?
Do you want me to take that one, or?
I'll let you start.
Okay. As in all things, Micah can keep me honest and accurate here. So there's a few elements to managing security for Kubernetes, especially when you're running at our scale. So we work closely with the community on security and related efforts, and this includes being active members of the Kubernetes Security Response Committee, the Security SIG, and the CNCF Security Tag. We work closely with the Security Response Committee on any embargoed security issue. And that helps us to ensure that our customers and their workloads are protected from new or novel issues before they become a real risk. We regularly make updated armies available for download, which might include more routine updates, performance changes and such, but also regularly contain CVE updates. We recommend that customers are always running the most recent army for the version of Kube that they have deployed. We provide an extended window of Kubernetes version support, normally about a year out. So basically, we will take security updates and make sure that any of our supported Kube versions are patched against those CVEs. And one of the more interesting things is we support automatic upgrading of clusters on versions of Kube that are going out of support. So we actually ensure that our customers stay on supported versions of K8s by auto upgrading them at the tail end of our support window.
Yeah. And to tie into,
I was going to say,
sorry,
I was going to emphasize how important it is for customers to stay up to date. Although we give them, an automated mechanism for upgrading their clusters, it's really important that they stay current with Kubernetes.
Yeah. To tie into your previous question about Fargate, that's one of the advantages of Fargate is that patching, like the automated patching. When there's when you hear about a container CVE or a kubelet CVE in Kubernetes, you know that your next Fargate task is going to be patched for that, and you don't have to worry about it. Also, with the Fargate model, when there's a container breakout type bug, like it's always less of a worry because you only have one pod per Kubernetes node. But that's just one of the advantages that Fargate brings.
Okay, let me change gears a little and ask a slightly different question. So the AWS Load Balancer controller already integrates with Amazon Certificate Manager for certificate lifecycle management and assignment. What sort of options are available for customers who want to use ACM without the Load Balancer controller?
Yep. Yeah. So as you said, the Load Balancer controller that we support, it's open source. It's on GitHub under the Kubernetes org that we maintain and help keep up and add new features to. Maintains network load balancers, application load balancers. You can put the ACM certificates that you already have on those load balancers to secure connection. But as your question is, okay, if I'm using something else or certificates within my cluster, how do I secure that communication? ACM, Amazon Certificate Management Service, has a feature for private certificate authorities, and we AWS just launched a add-on to or a plugin for the Cert Manager project. It's another CNCF project that's built on Kubernetes that lets you request certificates from your ACM private certificate authority. So if you want a pod to have a cert that to secure communication within the cluster or from external sources, you can use ACM generated certificates that are backed by an HSM and everything to generate certificates into your cluster.
Great. Yeah, that's a really useful feature. All right, let me switch gears a little again and ask a different question. So when talking to customers, it seems like it's not terribly uncommon for them to have multiple clusters nowadays. There may be customers that run a few very large clusters, but increasingly customers are creating multiple clusters, perhaps for different environments or for running different sets of applications. And applying configuration consistently across clusters can be a challenge. And especially as your number of clusters increases. And so how is AWS thinking about this problem? And this is for either Rob or Micah.
I can take this one.
Okay.
Yeah, I think there's two primary approaches here that we really are seeing our customers get behind and working well. One, which I'll touch on lightly, is this thing you might have heard of called GitOps, or Git-based configuration of a cluster. And we use, there's a lot of different, or a number of different engines for that. One that we use in EKS Anywhere and bundle in is Flux. And that sort of provides like the consistency of state in the cluster and continuous enforcement. The second part to this is sort of visualization, so what's actually going on. And we recently launched the EKS Connector. This provides, it's an agent that you can run in your cluster, your EKS Anywhere cluster, your cluster in any other cloud provider, your cluster that you manage on your own hardware. It doesn't matter where. You can run the EKS Connector and have in the EKS console visualization of the resources in that cluster. And you can see it right next to your EKS clusters in AWS, in AWS Cloud. It lets you sort of see side by side, is the configuration of my on-premise cluster or my cluster in another cloud provider the same as it is in EKS.
Nice. Rob, any thoughts?
No thoughts specifically. I don't have anything to add to what Micah was saying, but I was just reminded that you asked a question about CVEs a minute ago. Micah and I actually have a Kubecon talk on Friday, which is a Hitchhiker's Guide to Kubernetes Vulnerabilities, where we go pretty deep on this and we look at the distribution of vulnerabilities across the entire lifetime of Kubernetes and try to figure out if, from the trends we're seeing, do we think Kube is getting more secure or less secure? Do we think vulnerabilities are more of a concern or less of a concern? And how well do we think that the community is really managing this, and how well do we participate in that? So just a quick plug for that on Friday afternoon, the Hitchhiker's Guide to Kubernetes Vulnerabilities.
Thanks, Rob. And I think I'll ask a final question before we open the floor to questions. But what are you looking forward to in 2022 and beyond? Bob, talked about a lot of really interesting things that are coming down the pike. I'm personally excited about where we can use eBPF. I'm also looking forward to the next version of pod security policies and how EKS can make use of Bottle Rocket, not only for running EKS clusters in the AWS cloud, but also with EKSD and EKS Anywhere. Any particular things that you're looking forward to?
One thing I'm really passionate about and have been able to help build a few features and parts of EKS is the identity space. So I think you'll see better integration with EKS and IAM, both directions, in and out of AWS. I think you'll see. I'm also working on EKS Anywhere, and that's an area I'm really excited about. So I think both just in the feature side and then on the security side, there are going to be really neat things coming out of that in the next year.
Great. And Rob, anything stand out for you?
Again, I'm in danger of just repeating Micah. I think one of the most exciting areas here really is, in security and observability. We're just now learning as an industry the value of something like eBPF. We're just now starting to exercise some of the edges of it. And I think the ability it's going to provide us to understand and profile the correct or abnormal behavior of pods is going to really open up a lot of nuanced approaches to security in Kubernetes. I think over the next several years, we're going to see advancements in mechanisms to automatically protect clusters and mechanisms to reduce down and scale down risk over time. In the more near term, one of the things I'm really excited about is the move away from pod security policies and into pod security standards. I think the main point here is that pod security policies were hard and people often got them wrong. And a lot of compromises that were seen in the wild were a result of people making mistakes in the amount of privilege that they would allow a pod to have. I think the move from pod security policies to standards is an interesting one because it actually signals Kubernetes moving away from the business of trying to govern policy, right? There are entire huge open source projects, many of them, dedicated to just trying to figure out how to correctly express and apply policy. And it doesn't necessarily make sense for a container orchestration system to try and also be one of those things. So what this move is a gentle push to the community to go and use one of these more accomplished platforms like OPA or Gatekeeper or Keyverno. And pod security standards exist to provide what I call footgun protection, right? They're the very basic, like tiered sets of standards. There's privileged, baseline, and restricted. And these exist for you to kind of be able to categorize a pod into one of these three and try and constrain it in a sensible way. I think that the general direction we're going in is interesting. I expect to see a lot of providers become opinionated about whether they really like a Rego based language or whether they want to go with something like Kyverno or something else. And as Michael already said, there's really interesting opportunities for integrations with things like AWS IAM and other stuff in the future. So I think the entire realm of policy and authorization in Kube is something that's going to change a lot over the next couple of years and be very, very interesting from a security point of view. And I think that our ability to get enhanced observability and understanding of what pods are doing at runtime through things like eBPF are also going to be very interesting. So we're going to kind of be able to top and tail this security problem. We'll have better ideas of what we actually allow to go into a cluster and better observability of what they're doing once they're in.
Thanks, Rob. So I'm going to invite Justin to rejoin us here. And Justin, are there questions from the audience that we could answer while we're here?
I was really interested in what Rob was just saying, because I never thought of pod security policies going away as a great thing for the community, because it does let security of pods be more refined, and we can really focus in on what individual users and companies need based on, it's not just a generic, hey, this is a policy you can like. The pod security policy is great for the 80% use case that Rob was saying, like the ecosystem changes quick, and not having to roll that into Kubernetes allows use cases to be separated. Depending on what Kubernetes version you're on, Kubernetes can keep going forward, and you can kind of manage all the
Hey, Justin, I don't know if it's me, but it's a little hard to hear you.
All right, we'll try to
turn
my mic up a little more. There are a couple questions from chat that I wanted to bring in. One of them, where'd it go? Was just around viewing EKS control plane details. What recommendations do we have for customers running EKS, especially hosted EKS in AWS, to be able to see what's going on in their clusters on the control plane side?
Sure. So I could start. We do expose the metrics endpoint for the control plane, and customers can configure the Prometheus agent to scrape that endpoint and surface those metrics in a dashboard like Grafana. That's perhaps the easiest way that customers can get metrics information from the control plane.
Yeah, go ahead. Robert, you got something to say?
Yeah, I was just going to add that the EKS Workshop, I think, is a useful way to help people understand a little bit more about how EKS is built and how it works. This is actually published as a standalone resource on EKSworkshop.com. And that's a very good series of tutorial-like lessons that you can work through at your own pace to help you really understand how EKS is built and how you can use it to deliver value.
Yeah, there's a ton of content in there. Everything from running clusters to exposing those logs and metrics to be able to see what's happening in the cluster. The other point I could also mention is EKS clusters can log into CloudWatch Logs for any sort of logs that you need to get out of the cluster itself, see what's going on, and obviously everything else from CloudTrail and for access management, actually seeing API calls and that sort of stuff.
Yeah, and I know that we have had conversations about how we can make this simpler for customers by exposing these for them within the EKS console. So today, while there is work that customers need to do to scrape metrics for the control plane, we do intend to make this simpler.
Cool. Last question that I saw in chats, some CKP Cloud 12. Is there something like Cubebench that we recommend for EKS? Is there anything specific about Cubebench that we have integrated, or do we recommend people use something like Cubebench to look at their clusters?
So Kubebench can be used to analyze the conformance with the CIS benchmarks, so at least the worker nodes. You don't have the ability to run that against the control plane today. We have done work to integrate Kubebench with Security Hub, so you can surface violations that Kubebench detects directly into Security Hub.
Am I muted?
Nope, we
Am I
can hear you.
muted?
Nope, we can hear you.
Okay, sorry. I saw the icon. Forgot.
Yeah. The other thing I'll add is for EKS Anywhere, you can run Kubebench and you have the full Kubernetes control plane, so you can validate that it's running with the correct configuration. We also run that test. We configure the EKS Anywhere clusters that way, but that's one other flavor of EKS that you can run Kubebench against.
Yeah, and I was going to point out that, I mean, EKS is Kubernetes, so if you have a standard tool that you want to run, you're welcome to run it. Just varying degrees of, as it was described from Jeremy, ownership of responsibility for those clusters and security might rely on AWS versus you, but as Micah pointed out, EKS Anywhere runs completely on-prem, which is coming up in about an hour. We'll have EKS Anywhere demo, which I'm all ready for. So thank you everyone for coming for the security panel. Next up, we're going to do some roadmap overview. It's going to be Alan and Mike are going to talk about what's coming up in the next year for EKS, EKS Anywhere, and everything on AWS. So stay tuned. We'll be right back.